Assalamu alaikum, dear students. Welcome to the lecture of the classical mechanics. In this lecture, we will discuss the solution for the problem number 7.23, which says that consider a particle of mass m moving freely in a conservative force field whose potential function is u. Find the Hamiltonian functions and show that the canonical equation of motion reduced to Newton's law. Use rectangular coordinates. This is the hint. The first very thing is that we have to find the Hamiltonian function. The Hamiltonian function in generally can be written as h is equal to sum of p q dot minus L. This summation in means if we have many coordinates, so we will just sum it. So summation pj q dot j minus L for a particle which moves freely in a conservative field with the potential u. The Lagrangian in rectangular coordinate will be equal to t minus u, and kinetic energy will be equal to m over 2 x dot ka square plus y dot ka square plus z dot ka square minus potential energy. This is the kinetic energy for x axis, y axis and z axis, because our particle is moving in a conservative field and that particle is also moving in a three dimension, mean x, y, z. So m kinetic energy will be equal to m over 2 x dot square plus y dot square plus z dot square minus potential energy. And then linear momentum component in rectangular component will be equal to px is equal to partial L over partial x dot. We have Lagrangian, we can find its px component with the help of this Lagrangian. So px will be equal to partial L over partial x dot. We need to just take the derivative of Lagrangian with respect to x dot. This will give px. So when take the derivative of this Lagrangian with respect to x dot, it will give us mx dot. And similarly py will be equal to partial L over partial y dot. So it will give us my dot, and similarly pz will be equal to mz dot, because pz will be equal to partial L over partial z dot. Then for Hamiltonian we need, you know that for Hamiltonian we need sum of j p j q dot j minus L. It means sum of pj means px and similarly qx dot, similarly then plus, so mx dot and x dot will become mx dot square. We have px, py and pz. We will plug these equation, which are jointly known as written as equation 2. We will plug this equation into this expression 1. So this will give us Hamiltonian, which is equal to pj. For if we expand this, so it will become like px similarly and x plus py and y, x dot y dot plus pz and z dot minus L. So px is equal to mx dot. So this mx dot, we will put mx dot and x dot will become x dot square plus py is equal to my dot. So we will pick this equation, this value from here to this equation. So it will become my dot and my dot square plus mz dot. So we will put this equation value at here, mz dot, and multiply by this z dot. This will become mz dot square minus Lagrangian, which is equal to this mx dot square plus y dot square plus z dot square minus u. Okay, then you know that this is mx dot square, and then this is half of mx dot square. So 1 mean the coefficient of this is 1 and the coefficient of this is 1 over 2. So 1 minus 1 over 2 is 1 over 2 mx dot square, plus similarly we will subtract this my dot square with respect to minus 1 over 2 and my dot square. means just we have to take into account the coefficient of this whole is 1 and the coefficient of this whole is 1 over 2. The 1 minus 1 over 2 will become 1 over 2 and the rest of r will be the same, minus this minus, when this minus sign operate on the inside of the bracket, so it will become plus u. So we will left with m over 2x dot square plus y dot square plus z dot square minus plus u. So you know that this mx dot square over 2 plus my dot square over 2 plus mz dot square over 2 plus u, this is just equal to, if we multiply this expression with m and multiply and dividing this expression with m, so it will become m square and x dot square, so m square y dot square plus m square and z dot square. So the above will become px square over 2m, py square over 2m plus pz square over 2m. So just plus potential energy. So our Hamiltonian will be equal to kinetic energy plus potential energy, which is just a total energy. We can write this kinetic energy mx dot square over 2 like this, mx dot square over 2. If we multiply this expression with the m, so it will become m square x dot square over 2m, and then mx dot square is just like px square over 2m. Similarly for y dot square, similarly for z dot square, so it will become px dot square over 2m plus py dot plus potential energy. So this whole is kinetic energy and this is potential energy. So these, which is just the total energy. And then the requirement of the question is show that the canonical equation of motion reduced to Newton's law. Okay, I will first erase this all stuff so that we can write. Okay, so we have to find and show that the canonical equation of motion reduced to Newton's equation. We have to reduce the canonical equation to Newton's equation, use rectangular coordinate. Okay, this is px is equal to mx dot, py is equal to my dot, and p is equal to mz dot. These are the canonical equations, and we have to reduce this to Newton's law. You know that if we take the derivatives of this with respect to time on both sides, so this will become px dot, which is equal to this m is constant, so derivative of x dot will become mx double dot, and this is px dot, mean derivative of a momentum. You know that which is equal to and f force, which is can be written as dpx over dt. This px dot can be written as dpx over dt, which is equal to fx. So fx is equal to mx mx double dot. Okay, this is not square. Similarly, when we take the derivative on the both sides, so it will become py dot, which will be equal to my double dot. Okay, so this is fy. So fy is equal to my double dot. It means fy is equal to my double dot, and similarly fz will be equal to mz double dot. So this is nothing but Newton's law, Newton's second law, and this is for all of the component x, y, and z. Fx is equal to m into a, and similarly fy is equal to m into a. This is acceleration. X double dot is acceleration along x-axis, and y double dot acceleration along y-axis, and z double dot is acceleration along z-axis. So fx is equal to m multiplied by ax and Fy is equal to m and acceleration along y, and similarly Fz is equal to m and acceleration along z. These are the Newton's law, which are the requirements of the question. So I will stop at this point, and inshallah meet will in the next lectures.